Welcome everyone. Welcome to this particular lecture called Digital Multimeter. So we will see what are the different blocks of the digital multimeter in its internal circuit diagram. So let us start. So what is a digital multimeter? It is a very common and important lab instrument. It has mainly three different meters in one. What is that? It is used to measure the AC or DC voltages. It is used to measure AC or DC current and resistance with digital display. So it will give us digital output which is very accurate. So multimeters are those measuring instruments which can be used to calculate the multiple circuit characteristics. Now let us see the block diagram of the digital multimeter. So in digital multimeter, we have seen there are two probes. One is a red probe and another one is a black probe. The red probe is connected to the positive and black probe it is common or grounded. So here the rotary switch is nothing but the knob of the multimeter. Okay. So if I want to measure the unknown resistance, I need to set the knob at position number 1. Similarly, if I want to measure the unknown AC voltage, I need to set the knob at 2. Then if I want to measure the AC current, I need to set the knob at 3. If I want to measure DC current, then at 4. If I want to measure DC voltage, then at 5. So let us see, first we want to measure the unknown resistance. So from the constant current source, let us say some known current, for example 5 milliampere is flowing through this unknown resistance when my knob is at position number 1. When that the known current flows through this unknown resistance, we will get some output voltage. This buffer amplifier is here in order to match the input and output impedance. Let us say here we are getting some 5 volt output. So this analog output is because we have given that analog input signal. Okay. Now this signal will be converted to the analog to the digital converter. So this ADC converter will convert that 5 volt voltage into some digital pulses. Then the decade counter, this counter can count the pulses and it can count maximum 10. So if my value of the voltage is 5 volt, so it will count 1, 2, 3, 4, 5 like that. Till 5 it will count. And my known current value is 5 milliampere and if I am getting the voltage 5 volt, so 5 volt by 5 milliampere, that means 1 kilo ohm will be the value of this unknown resistance and that will be displayed on the screen. So all these calculations they happen internally. We set the knob at the particular position and we get to see the display. But before that result appears on the display, all these internal operations happen. Next, if I want to measure the AC voltage, I need to set this knob at position number 2. This knob is nothing but the rotary switch. So this AC voltage, if it is the magnitude of the AC voltage is high, so it will be reduced by the AC attenuator. Attenuator is there to reduce the strength of a signal. So still it is a AC signal at the output of the attenuator. Now I need to convert that AC voltage to the DC voltage. This full line is my DC. Through the rectifier, I can convert the AC voltage to the DC voltage and that will be given to again the ADC, which will create the digital pulse. Counter will count the pulse and it will be shown on the display. Next, if I want to measure the AC current, I need to convert that current to voltage. Whenever we have some input current quantity, it is always suggestible to convert into the voltage. So in that way our calculations measurements will become simple. So this current to voltage converter, this AC current is converted to the AC voltage by using this current to voltage converter. Then that AC voltage is given to the rectifier. What it will do, it will convert that AC voltage to the DC voltage. As I told, this entire line is my DC. So that DC voltage will be given to this ADC. This ADC will generate the digital pulse, then counter will count the pulse, and the value will be shown on the display. When we measure the DC current, here I don't need to, since it is already a DC quantity, I don't need to convert it into the like DC anymore. But since it is a current quantity, I only need to convert this current to the voltage using current to voltage converter. Then the process is same, it is fed to the ADC, then counter will count the pulse and will be shown on the display. Then if I want to measure this DC voltage, so here it is already a voltage quantity and it is already in DC, so we don't need any rectifier or any current to voltage converter. But if the amplitude of the signal is high, that can be reduced using the DC attenuator and can be directly given to the ADC. It will convert the analog signal to the digital pulses. Ticket counter will count the pulses and it will be shown on the display.